name is Dr. Esther Trufan, and in this video, I'm going to demonstrate a thermochemistry experiment. For this experiment, I'm going to use a Magic Cook pouch, which you can purchase from Amazon. I will also use some deionized water, and this is an add-on. If you have some universal indicator or any other indicator, feel free to use it for today's experiment. If you don't, you will not lose much other than a very interesting color change that can be observed. For our additional equipment, we're going to need a thermometer because for all thermochemistry measurements, we need to monitor temperature changes. We will also need a scale and a weighing boat to monitor the mass of the materials we're working with. We're going to need some water, so we will approximate its volume, but then record its exact mass. And finally, there is no thermochemistry experiment without an insulated system, which in this case will be a coffee cup calorimeter, which consists of 2 nestled styrofoam cups. To demonstrate the experiment so that you can see what is happening inside the styrofoam cup, today I will replace the styrofoam cup for my experiment with a beaker, but you should definitely do your experiment inside the styrofoam cup. So every time in the course of this video where you see me working with a beaker, imagine that you're working with a styrofoam cup instead. So the first thing that we're going to do is turn on our scale. Once we do that, we place our styrofoam cup on the scale and we record its mass. The mass of my beaker and your styrofoam cup is 145.24 grams. Next, I am going to measure approximately 100 milliliter of deionized water. I am reasonably close at 95.4 milliliters. When I transfer the water into my beaker, and you will transfer it into your styrofoam cups, the mass on your scale will change. In my case, it became 240.19 grams. And with that, I am done with my styrofoam cup and the water. I can set my graduated cylinder to the side. Next, I am going to place my weighing boat on the scale and tare it. I want to know the exact mass of my Magic Cook pouch and the chemical within it. I will open it up and carefully place the Magic Cook pouch on top of the weighing boat. In my case, it weighs 21.38 grams. Before I transfer it into my coffee cup calorimeter, I will do 2 things. First, I will record the initial temperature of my water. This may take a minute or so. And the temperature of my water is 20.9 degrees Celsius. The next thing I'm going to do is add a drop of the universal indicator. Maybe 3 or 4 or 5. Just enough to give us a color change. The universal indicator should be a yellow-green when it's neutral, and it should be neutral when the only thing I have in my styrofoam cup is deionized water. I can set it aside now. And very carefully pick up the Magic Cook pouch and place it inside my styrofoam cup. And you can already see somewhat of a color change happening here. It turned purple, and that means it is quite basic at this point. The temperature hasn't gone up much. It is only around 21 degrees Celsius. But this is where some patience will pay off. So just use your thermometer to gently hold your Magic Cook pouch under the water level. And then slowly you'll start to see some bubbling form. And if it tries to escape, you need to gently coax it back under the water level. At this point, the temperature should be going up at a relatively fast pace. My temperature is already at 81 degrees Celsius. As the reaction progresses, we're looking for the highest temperature that our solution is able to attain. and we're going to record that highest temperature attained. Because I am performing the experiment in a beaker, it is easy for me to lose heat to the environment because glass is not a very good insulator. But if you are doing your experiment inside a styrofoam cup, your temperature should remain relatively high for an extended period of time. From here, you will need to continue the experiment until there are no more bubbles. Even if the temperature starts falling, you need to wait until all the bubbles are gone and the temperature of the water, well, in this case, the solution, becomes manageable. So think no higher than 50 or 60 degrees. At that point, when the bubbles are gone and the temperature becomes manageable, then you will weigh your styrofoam cup and your mixture that's contained within again. The highest temperature I obtained so far is 89.4 degrees Celsius, and it seems to keep rising at a very slow pace. From here onward, there are only two things to do. Have patience until all the bubbles are gone and your temperature cools up enough so you can cautiously transfer your styrofoam cups onto a scale. And then the last piece is going to be weighing your styrofoam cup with the water and the magic cook pouch inside. It has been approximately 25 minutes since we started our magic cook pouch experiment, and the temperature of my solution here is just under 50. It is 49.8 degrees Celsius. At this point, I will call my experiment complete. The last bit of task that I have here is to remove my thermometer, turn on my scale, tare it so it shows 0.00, and I will place my beaker, your styrofoam cup, with your solution and your magic cook pouch on the scale and record your final mass. For me, that is 235.22 grams. Now, from this final mass, I will subtract the combined mass of the beaker, water, and magic cook pouch. This should determine how much water was lost or evaporated in this process. And the mass of evaporated water should help me determine both the enthalpy, entropy, and the free energy of this reaction.